Hello, welcome to By Excellence Tutorials. At By Excellence Tutorials, we tutor courses such as mathematical methods, chemistry, physics, statistics, biology, and many other courses. Now, we started looking at differentiation, and we dived into looking at basic differentiation rules. We've done a number of rules. So if you've missed any video, you can go back and check their videos on differentiation. Now, we have been dealing with the videos. We have been dealing with the differentiation of late, power rule, first principle, product rule, quotient rule. Now, what if we have a function of a function? Is product rule going to be useful? No. Let's take, for instance, if you have a function of power 2, you are able to expand this function easily without having any difficulties. It's easy to expand this one, and then you use power rule to differentiate. But what if we have a function? It's going to be tedious for you to expand this 10 times, this function 10 times. This is where now the chain rule comes to be applicable. Okay, so let's see how we get to chain rule. So if we have this function, y is equal to x minus 1 to the power 10, okay, we are going to let the function, let's function inside there, we're going to let it be equal to u. So this function now is going to look like y equal to u to the power 10. So you can see that things have been simplified here now. Okay, things have been simplified, and we are going to differentiate this. So we're going to differentiate u with respect to x, of which we get 1 with respect to u, of which we're going to get 10 u to the power 9 using power rule. Okay, so now this function, we are going to see that the y as when we multiply changing u with respect to u. Okay, because changing u and changing u are going to cancel, and you're going to name it changing y with respect to x. So changing u with respect to x is basically 1, and then changing y with respect to u to the power 9, of which this gives us 10 u to the power 9. Now remember that we had made an assumption, okay, of letting u being equal to x minus 1. So we reverse that assumption by putting u represent. So we're going to have 10 open bracket. This is how you get to apply a chain rule, a function of a function. Okay, let's look at another example. We have 1, the power 4 squared minus 1, of which that function will look like respect to x is respect to u is actually 4u cubed. So u and u is x squared minus 1, the power. We have u respect to u. So we have 2x squared minus 1 to the power 3. So what we're going to x squared minus 1. That is how you get. Pause the video and try to solve using chain rule. How do you differentiate this one? How do you differentiate this one? Pause for 2 minutes and solve it. I believe you paused and you solved this one. So this is how x is 2 and y equal to y with respect to x equal to 7. Changing y with respect to x is basically change respect to x, which is 2 times gives us 14 u to the power 6. So we replace, and then we're going to have like that. That is how it is done. Okay, so we try to solve also another question. Okay, and this question, it's on the same chain rule, where we get to apply chain rule, but it's a little bit different. Yeah, it's a little bit different from this one that we are doing. So it's like this, root of 1 minus 8 x squared. Okay, so the first thing we can do is that 1 minus 8 1 over 4. So this one can be written like that, 8x squared to the power 1 over 4. So negative 16x. With respect to u, we're going to have 1 over 4, u minus 1 there, 3 over 4. Like that. And we replace where we're going to have over 4. What is our u? Our u negative 3 over 4 is equal to negative 4 over 4. So what we're going to have is 4 into that, 1 3 over 4. So that is how you get to apply chain rule function of a function. I believe that was so helpful. So kindly share the video, give it a like, give it a share, reactions, and also make sure you subscribe and click on the notification bell. And if you're looking for a private tutor, get in touch with us on the details that have been put in the description box. Thank you for your time. See you in the next video.